Hi, how are you all? I'm Dr. M. Karmaksha. In this videocast, I'm going to explain how to perform normality test using Skewness and Kurtosis. So there is a particular test called Jarque Berra Test. We simply call it a JB test. And this test is actually a composite measure of Skewness and Kurtosis. So the formula for Jarque Berra Test is n times Skewness square divided by 6 plus Kurtosis square divided by 24, and this particular calculated measure roughly equals to chi-square statistic with 2 degrees of freedom. Okay, and there are also other ways to do alone based on skewness and kurtosis. In case if I choose to test the normality only based on skewness, then I just have to take the skewness divided by square root of skewness divided by square root of 6 by n. That is actually the standard error of skewness, and for kurtosis divided by square root of 24 by n. That is what is the formula. Okay, and when I divide the skewness or kurtosis with the respective standard errors, that measure is roughly equal to z statistic. And now the couple of z statistics, so that is what we call transformation. So we are going to transform the skewness and kurtosis measures into respective z statistics. Otherwise, if you just wanted to carry on with Jarque Berra test of normality, then we have to calculate Jarque Berra statistic based on the skewness and kurtosis. This is actually the procedure which is involved in performing a normality test within Excel. There are other softwares where it is possible to do the same thing, but we don't need to do normality test, especially the documentation which I am showing you is actually the documentation which is related to our language. So there the things are straightforward. We don't need to calculate the skewness. There are so many other tests which helps us by default. There are functions, inbuilt functions, which we can use to perform normality test on underlying or base data sets, data variables, or whatever it is. So for this demonstration, I have some sample data set. This is just a hypothetical scenario where I simulated data set. I just wanted to verify if the salary is normally distributed in this data set or not. So the intention is being that I wanted to carry on with my other test like F test and 2 sample T test. But before going to do one of the prerequisites to perform such a parametric test like Z and F, I need to verify whether my underlying data distribution or data variable is normally distributed or not. So how are we going to do that? So in Excel, we've got a beautiful function called skewness, skew. So this measure need to be close to 0, which is not actually. Now this is skewness, and now I need to go for SC of skewness, the standard error of skewness, which is square root of. There are so many versions of there are so many formulas related to calculating standard error of skewness. This is one of the formulas which I'm using. There are different types of formulas, and it doesn't matter, like you can use any one of the formulas in order to say. Here the formula which I'm using is square root of 6 divided by n. So that is, now square root of 6 divided by n is count. Okay, and now these values. So how many values I have is what is count. Yes, so this is the standard error of skewness. Now we can just simply calculate the z statistic by dividing the skewness with the respective standard error. Now this is so if you see, actually this is there is a convention that if the z value is close to or less than 1.96, so at 5% significance level, the data is normally distributed. See here the z value is roughly, so which is 1.3 is less than 1.96, so at 95% confidence level or at 5% significance level, I can infer that the salary distribution in this data set is normally distributed. We'll just go ahead and do a little more. This time I'm going to calculate the kurtosis. and we'll try to perform. Okay. Jarque Berra Test. Kurt is the function to calculate the kurtosis, and now standard error of kurtosis is square root of 24 divided by count of rows. I mean, you can also use number of rows, doesn't matter. I think I have to close one more bracket here. Now this is the kurtosis and this is standard error of kurtosis. Now in order to convert that into z statistic, we have to divide the kurtosis with the respective standard error. Now it is minus 0.86, so we can simply, so there is no rule like kurtosis if it is if the z value is 1 less than 1.9, but kurtosis, that rule applies. Now so what are we going to do? So one way is to go here and calculate the p-value for this z statistics. How are we going to do? Norm s dist, and this is z value for cumulative s true, so like that. So this is actually the p-value for this z value. Now by looking at this p-value, it is very clear that we fail to reject the null hypothesis, which is nothing but the salary is normally distributed. Now the same way we can also do norm dist s dist sample distribution, something like that, and this is the value, and cumulative s, of course, I want true, and then yeah, it is the p-value is greater than 0.05. so even through kurtosis value, both skewness and kurtosis do emphasize the normality in the underlying data variable. So this is normally Pucker normal distribution. So this is how we carry on normality test using skewness and kurtosis. I mean, converting the skewness and kurtosis into respective z values and calculating the p values for those z values, and finally we end up with now how to perform the Jarque Berra test. So now the formula is the n multiplied square skewness square divided by 6 minus kurtosis square divided by 24, which is roughly, so that is JB stat. Okay, I have shown you earlier. So n is the count of so I can straight away take 30 here and multiplied. I can open one more bracket for skewness, so skewness square, so that is the divided by 6, close the bracket, my skewness part is over. Now plus, and open the bracket for kurtosis, and the kurtosis square divided by 24, open the calculation for kurtosis, and again close one more bracket because for the, so every open bracket must be closed. That is what is the, now n multiplied skewness square divided by 6 plus kurtosis square divided by 24, that is what is this value. Correction, do you want to accept the correction? Yes. So this is actually the chi-square value. So how are you going to calculate the chi-square? Chi-square sample distribution. So okay, it is not there, dist. Okay, we will go for oh yes, okay. So chi-square statistic and 2 degrees of freedom. Please be cautious. The degrees of freedom need to be, that is actually the theory. Okay. Now we are trying to calculate the p-value for this chi-square statistic, which is what is this? Yeah, cumulative. True. So now, so the p-value is greater than 0.05. So even even the Jarque Berra statistic also do emphasize the salary distribution is normally distributed. So I have shown you 3 ways of calculating 2 different statistics. One is z statistic and chi-square statistics through Jarque Berra test, and compute the p-values and take the inference whether the study variable is normally distributed. In this case, our study variable is salary. We are interested to find out whether the salary variable is normally distributed or not. So in all cases, we fail to reject the null hypothesis, and we infer that the salary particulars of these individuals, 30 individuals, are normally distributed. Thank you for watching this video. Stay tuned for the new content, and bye bye for now.